Okay, good afternoon, everyone. As I posted in the group, myself, Dr. Ramchandra, from Mechanical Engineering Department. For this 5 weeks, I'll be engaging the engineering graphics subject for you. So, the entire subject I'll be revising. So, wherever it is possible, I'll give more the importance over there, and I'll give the more the information about the drawing. Okay, so all of you have studied the entire semester. A few classes you had offline classes on board, and few classes even the online classes also you had. So let me start from the basics. So this class only the basics, the foundation I'll be giving. So next class onwards I'll start the projection of points chapter. I'll start. The subject, the name of this particular course is engineering graphics, which is also called as engineering drawing, computer aided engineering drawing, geometrical drawing. So in so many the names we can give. The name which is given for your subject is engineering graphics or engineering drawing. The subject code, everything. It's a 4 credit course. 1 second. So it's a 4 credit course. So there's a course code is MEC 152. That means 2 hours theory per week. So that's what we used to take when the classes were started in the beginning of the semester. And there is no tutorial class for this. Lab hours is kept for 4 hours, 2 plus 2 hours. So total it's a 4 credit course. So weekly we used to take 6 hours during our regular the classes. So here in your timetable by mistake 9 to 1 they have allotted only 2 hours. So the remaining the 3 hours I'll be taking afternoon. So this is regarding your course, the code and course name. And let me start with the before coming to the what exactly the engineering drawing or graphics. Let me start from the drawing word. Okay, in drawing it might in your childhood, in your school days, in many competitions you have participated, or your many drawings with your own. So a drawing in general, if we want to uh, discuss about this, as well as if we want to define any number of ways, if and we can define this drawing word. So in general, the simple way how to define this drawing is nothing but it's a pictorial representation of any object is called as a drawing. So for example, in a painting, so your imagination you may put it okay on your the piece of paper or in a drawing sheet. So whatever it is there in your mind, that also you can represent it. That's what a picture, or else if I give some sketch or some object, I may ask you to draw it on a drawing sheet or wherever it is required. So by looking at, you will be drawing the exact the shape and size of that particular the picture. That's what in general how I can define this drawing, in the sense it is pictorial representation of any object which is given to you on either on the, if it is either by using any software, either on the system screen, or else on your sketchbook or on a drawing sheet. So then we can call that as a drawing. So in general, okay, I'll come to the engineering drawing later. There are mainly we can classify the drawing into two categories. One is artistic drawing and second one is engineering drawing. So, okay, so let me give you some example also for this. The artistic drawing. So you may see many the sceneries and all. Okay, so whenever you like any sceneries and all, okay, you can what you will going to do? You will buy that and on a wall you will get, correct. So this particular example which I have shown here, it is an artistic drawing. So based on the imagination or perception, or by looking at some particular the place or whatever it is, he has drawn this. So that's why we'll call him an artist. So he'll be drawing. So drawing whatever it comes in mind, or any particular some message you want to put, so you can represent through the drawing. So that's why if you visit any uh, drawing competition or any theme also will be given in some of the cases. Some theme is given, based on the theme you need to draw. So that's why this particular type of the drawings are called as the artistic drawing. That means the art of representation of an object by the artist based on his imagination or by keeping the object before him. So this is the artistic drawing. The artist based on his imagination or whatever based, okay, how you want to put his thoughts, he can represent in this way. Or else what I told you in some of the competition, okay, some Krishna idol, he may, okay, they may give you and they may put in front of you. You have to look at that the idol and you need to draw it. Okay, so this particular type of the entire category of the drawing is called as the artistic drawing, including your callouts, okay, the cinema posters, advertisement boards. Nowadays, this artistic drawing plays a very important role. Okay, and for advertisement especially, okay, the more it is attractive, the advertisement, the more the interest the people will going to give. That's why they will attract the customers for while marketing or while advertising their product. So painting, cinema poster, advertisement boards. So these are some of the categories which comes under this artistic drawing. Next, coming to the engineering drawing. So in simple words, how we can define this engineering drawing in the sense, any drawing which is prepared by an engineer for the engineering applications is called as the engineering drawing. The engineer might be a mechanical engineer, okay, for machine drawing he may draw, or he might be a civil engineer, some plan or elevation he may draw, or he might be a electrical engineer also, the circuits, the drawing and all he may draw. So in general, engineering drawing, how we can define, the name itself implies here, the drawing which is prepared by an engineer, irrespective of the type of the engineer, to fulfill the engineering applications, then it is called as the engineering drawing. It might be a building drawings, that's what I have represented here. Here the plan of the one apartment I have shown here. So where is the entrance, where is the lift, where is this, the steps, and which is the entrance, and what are all the commodities so we should have inside the apartment. Those things are mentioned here. It is called as the plan. Okay, suppose if you want to construct any house, you have to consult engineer. So according to your dimension, whatever the plot you have, according to your requirement, okay, how many bedrooms you have, how many, what is the size of your the kitchen, hall, and entrance, whatever it is. Based on your the inputs, he will prepare a drawing. Okay, so that is called as a plan. So this example which I have shown here, it is a building plan. Okay, where the civil engineer he may use it. And here the left side which I have shown here, this is an on component drawing. It's a one component drawing which I have shown, wherein all the details of the component which is shown here. Okay, so it's a flange housing plate which I have taken. In industry, if you visit any industry, okay, while manufacturing or machining any component, so directly you cannot machine or manufacture a component. You should have a drawing like this. Based on this drawing, see uh, the shape and size, what are the other the details which is given. Based on that only you can able to machine it. Okay, and even the exam building, roads and machine, etc. have given. I'll touch upon this the different types of drawings later also. Close the door, Tanish. Close it. As I told, engineering drawing, drawing which is prepared by an engineer for engineering purposes or application is known as engineering drawing. So, and also the second sentence which I have given, it is important. That means it is prepared based on certain the basic principles. We'll discuss that. What is this basic principles? Symbolic representation, what are the symbols that are used to represent the drawing also we'll discuss, and standards of conventions which are used. So the standards of convention that we will use, okay, it is the BIS, Bureau of Indian Standards, and different notations also we'll discuss. This is nothing but your engineering drawing. Once again I'll repeat this, a drawing which is prepared by an engineer for the engineering purpose, it is called as the engineering drawing. Okay, we'll discuss in detail. An engineering drawing is a two-dimensional representation of a three-dimensional object. What exactly you mean by this? Okay. Let me check your this thing. So whether starting from points, okay. So you have studied till the isometric, including your solids. Solids is a three-dimensional object where you will going to use, and isometric is a three-dimensional the representation. The three-dimensional you will going to get. So whether it is one-dimension object, two-dimension object, or three-dimension object, you are going to draw it on the two-dimensional plane only. Whether your piece of paper or the blackboard, wherever we draw, or else your computer screen, it has got only two dimensions, that is x-axis and y-axis. Z-axis is missing over there. That means what exactly you mean by the sentence? An engineering drawing is a two-dimensional, okay, representation of a three-dimensional object. It's a representation of the any drawing in a two-dimensional, but the dimensional object is three-dimensional object. For example, three-dimensional object, a cylinder is given to you. Okay, it has got a three dimension. While represent whether in either in the solids chapter or in isometric chapter, including all the three dimension, we are going to draw it to the two-dimensional plane only. Your the sketchbook or wherever you have drawn. So this is called as the engineering drawing. Next. The engineering drawing mainly deals with geometrical drawing. So as I told, it is also called as the geometrical drawing. Why the geometry? It is called geometrical drawing because to get the exact shape and size of your object, we need to use the geometrical instruments. We need to use the geometrical instruments. So that's why it is called as the geometrical drawing also, because we use geometrical instruments. It might be your scale, okay, compass, pencil, and your sketch square. So whatever it is, you're going to use. It is the art of representation of geometrical objects on a drawing sheet, and it is the foundation of all other engineering drawing. That's why the engineering drawing is also called as the geometrical drawing. So you can see applications of engineering drawing to build a shape. Actually, to build a shape, so directly I cannot okay build it when so as and it is required. We should have a thorough the plan before that. Okay, so the size, the shape, everything. Okay, you can observe here. For this is an example of the passenger ship. So where it carries the passenger from one place to other place, the aerodynamic design, everything. Okay, we need to have the drawing first, including your to construct any multi-storage building or any your to construct a house. I should have a plan as well as elevation also with me. Then only I can able to reconstruct it. It's a application of the engineering drawing nowadays. The many in our automobile sector, lot of the research and development is going on. So that means where to reduce the cost of the vehicle, how to increase the mileage of the vehicle, how to increase the efficiency, which are all the composite materials are the materials which are durable as well as strength wise it is good, and also the less weight. So in that aspect, say an aerodynamic design, so that not much friction when the vehicle is moving, the friction should not be there much. Whatever the wind, the velocity or the wind, the speed or the air which is coming opposite to the vehicle movement, definitely you have observed it, including your two-wheeler. When you are moving opposite to the direction of your wind, automatically it will resist your or it will resist your speed. Correct? So the design of your vehicle in such a way that okay, it's aerodynamic design in the sense even though heavy wind speed is there, you are riding a vehicle opposite to that, so that you should not give any opposition. I should not restrict the speed of your vehicle. So this is one example in the manufacturing of automobile structure, and this is a construction field. A earlier to build a house years together we need to wait. Nowadays, like a multi-storage building in either in if you search in internet or in the TV, television, or in a newspaper, every day if you see a lot of the changes you can see. In one day also some multi-storage in 72 hours the entire multi-storage building they have built it. So like that. So a lot of the automatic equipments they may use to construct the your the multi-story buildings and all, bridge structures, all those things. Now coming to the engineering drawing, under that we have different categories. So there are three different categories as I told. A building drawing is nothing but a civil engineer, they will use it. One example I gave. So whenever you are willing to construct on the house, you should visit a civil engineer. So you should give your the plot area size in terms of either 60, 40, 30, 40 or 20, 30, whatever it is, and you should give a requirement. Okay, whether one floor or two floor duplex or triplex house, all those. Based on your requirement, he'll prepare the drawing, plan as well as the elevation. So I'll come to that. What is plan and elevation later. So machine drawing. So to manufacture any machine or machine component, okay, we need to have a drawing before the production of that. So machine drawing, mechanical engineers they will use. And coming to the electrical drawing. So electrical or electronic engineers they will use it. Okay, if you visit any TV repair shop, so they will be keeping on the circuit with them, and they'll either motherboard or so they'll be keep on soldering and resoldering the connections and all. So that is a electrical drawing. So which is prepared by the electrical engineer. So these are all the three different the engineering drawing in general. Drawing equipments and instruments. As I told you, the engineering drawing is also called as the geometrical drawing because we use geometrical instruments to draw the drawings. That's why, since an engineering drawing shows accurate size and actual shape of the object, must be drawn to the scale with the aid of engineering the instrument. That in with the help of a drawing instrument. That means in a drawing, any drawing, shape and size both are important. First the shape we have to identify, then the size. Simply for example, if I ask you to draw a cylinder without giving any dimension, only I am giving a shape. So some of you can draw a cylinder, smaller cylinder, some of you may draw a bigger cylinder, some of you may draw still bigger cylinder. That means the option, only the option is given, the shape is given to you. Size, your own size you have taken and you have drawn. I cannot say it is wrong. Some of you might have taken 50 millimeter diameter cylinder and 100 millimeter height of the cylinder. So other people have taken based on their the choice. So that's why the shape is also important as well as the size is also important. Suppose if I give the details, draw a cylinder of 30 millimeter diameter and 50 millimeter axis height. So everyone, okay, have to draw the cylinder only with the actual the size which I have given. All the cylinders will look like similar. So that's why the shape as well as size is very important. That's why with the help of these instruments, okay, we can draw the drawings easily, quickly. What is the use of geometrical the instruments or the drawing instruments? Okay, with the help of these instruments, so we can prepare the drawing very easily, quickly, and more accurately. Accuracy is very important. So in engineering drawing, okay, the accuracy of the drawing depends upon the quality of the instrument. This is very much true. You might have experienced it. For example, okay, you might have used the eraser while drawing the drawing. Okay, suppose a good quality of the eraser you are not using it, then automatically instead of erasing the line which is prepared by you, it may wear out your paper itself. It may shear the paper itself. So that's why a very good quality of the drawing, the instruments you have to use. The more the quality instrument that you are using, the more the accurate drawings you can draw. Okay. So this is regarding drawing instruments. So these are all a few drawing instruments which I have listed here. Okay. So most of the drawing instruments you have used here. Let me drawing board. Okay. Since we are using computer aided the drawing, we won't use this. Okay. If you visit any industry or your the friends, diploma holders, or any, they may use it. A drawing board is a wooden board on which we need to keep our the drawing sheet, and we need to draw it. Drawing sheet, a sheet where we have to draw the our drawing. It is drawing sheet. Drawing sheet holder. So still you may see this drawing sheet holder. Diploma students or ITS students, they may use it, because we should not fold the drawing actually. If you fold the drawing and all, automatically, okay, so some of the fine tuning in the drawing I may not they see that. That's why always you have to roll it, and you have to preserve that while carrying from place to place. We may have to use a long folder, we have to keep it inside, and we have to carry. Set square you have used, both 45-degree set square and 30-degree, 60-degree set square you have used to draw the different angles. Okay. Compass you have used. Your real practice for engineering drawing, large size and small bow compasses are used. The compass you have used, okay, to draw the arc, circle, all those things. Divider. So divider you are not used. I will tell you the difference between your divider and compass. In the compass, one pointed end you will be having where we have to locate the center or wherever the point. Other end, so you have to insert your lead, so that the distance between the pointed end and the lead. So you have to take the dimension. You have to draw the circle or whatever it is. But in the divider, both the end will be having a pointed end. Okay, to divide the any line or to transfer the any dimension from one place to another place, we can use this divider. And scales 6" and 12". Okay, it is given in inch. That means so you know 15 millimeter the smaller scale you have used, as well as 30 millimeter the longer scale also you have used. Correct? 15 millimeters the plastic scale you have used for most of the drawing. 30 millimeter plastic also it is available, and even in workshop you might have used the steel rule or the steel scale, that is of 30 millimeter. Okay, a protractor you have used. If it is a standard the angle 30, 60 or 45, with the help of set square you can measure. But other than these the angle from 0 to 180-degree, you may use this protractor either to measure the angle or to draw any angle line. You have used the protractor also. French curves in your protractor, in your the set square, you may find some irregular shape of the curve in this way. Okay, that is called as the French curve. So I'll tell you what is the use of French curve. For example, in projection of planes, circular lamina you have drawn. Yes. So in the second position, so the circle look like ellipse, right? So there, all the points you need to join with the help of a smooth curve. Okay. So if you are not good with your free hand to join those points, you may use this French curves, the standard French curve, so that by coinciding 2 or 3 points, you can able to draw the arc. That is the use of French curve. Drawing pencils, you know HP pencils, correct? So the drawing pencils, we have many different types of pencils we have. So H represents hardness and B represent bold or the softness. Suppose for general purpose we use HB pencil, so it is neither hard nor soft. Okay, and if I keep on increase the H, 2H, 3H, 4H, 5H like that. Okay, so then the more the harder you find in your pencil, so H, so the more the lighter you can draw your line. Okay, and B, if I increase 2, 1B, 2B, 3B, 4B up to 6B, B means soft, that is bold. That means more the B in your pencil, more the thicker you can draw the line. That's all. So next, sandpaper, you not eraser is nothing but your rubber you will call. So a good quality of the eraser. Okay, will not obstruct the drawing. Drawing pins and clips. So if this you are not used. So there when I was explaining drawing board, simply I cannot keep the drawing sheet over there. While moving the instruments, the drawing sheet may get disturbed or displaced from its position. Okay. Then if that is the case, to keep the drawing sheet in that particular position till I complete the drawing, I may have to use the drawing clips so that it will hold the sheet in that particular place. So drawing clips, you might have seen that the tablecloth. So on your dining table or study table, we use tablecloth, right? Okay. So to retain the tablecloth and that we use table clips. So that is nothing but your the table clips and drawing pin and cellophane tape, your duster and drafting machine, mini drafter. The engineers in the industry they are going to use. So mini drafter. So it acts as a scale as well as protractor. With the help of that, any inclined line or any horizontal vertical line we may draw it. A drafting machine or set square. Have you seen? T square, the diploma holders they will use a T square. And small along with that like this and T square they will use. That is also for the same purpose it is used. So you use a sketchbook. The sketchbook which is given to you are different two types of sketchbooks are grid lines are given. One is the for orthographic projection you have used the orthogrids. That means a box, every box vertical as well as horizontal. So it is 10 millimeters size, correct? And for your the isometric grid line, it is 30-degree inclined on both the side, correct? And either in this direction or in this direction. And every box will give you ISO 10 millimeter. ISO 10 millimeter in the sense it is the actual 10 millimeter into 0.816. So I will come to that later. Roller scale you might have used here. The same line, if you want to have a parallel line, with the help of roller scale, you can move that. Roller scale, pencil sharpener, okay, mender, and sheet folder. So these are all some of the actual drawing the instruments. So few already have used it. So these are all some of the examples. So this is the divider, that's what I told. So we'll get both the ends pointed end like this. And this is pro circles, different the circles, okay, not to the scale. If you want to draw, you can, so for writing assignments and all, you might have used this, correct? So while drawing the circle, within that 1, 2, 3 question number you might have drawn. So this is protractor, 0 to 180 degree. You can measure the angle, you can draw any angle. So this is what I told. The pencil, more the H it is harder, the lead is harder, that means light lines you can draw. More the B, that is softer, the more thicker line you can draw. So this is compass. One end is pointed to one, other end the lead is there, so that you can draw any arc or the circle. This is 45 degree set square, this is 30, 60 degree set. This is a scale. Next, eraser. This is what I told. Different arc, the French curve which I have told. So like this, different irregular shape of the curves are there. With the help of this, we can use it. This is what I told, a mini drafter. You can see. This is a mini drafter. This is a drawing board. So the link is also given over there. Here, anywhere I can draw a line with the help. This is vertical line, horizontal line. There is a knob over here. By releasing that knob, I can rotate it by 360 degrees so that any inclination line I can draw. So this is the mini drafter. This is a sharpener. This is T square which I have told. The diploma holders still they use, they carry it. This is set square which I have told. This is a drawing board or sheet. This is a sheet. How the this is a set square. How we can draw the lines with the help of this, that the animation which I have added here. The clips are used to hold the sheet in that particular place. So like this. Just you can observe here. So layout of the drawing sheet. So we have the different sizes of the sheet, that I'll come to that. So always the layout of the drawing, in the sense, always at the right bottom corner we should have the title block. This is called as the title box. So why the title box? The name itself implies the title block will give you the entire information about the drawing, whatever you have drawn here. For example, name of the drawing is given here. Okay, which dimension is used, millimeter or whatever it is. whether the first angle projection system is used or third angle projection system is used. The complete, if you see this title block, the entire information about this drawing, whatever it is drawn over here, we can able to get it. So this is how the outline, the layout of the drawing sheet looks like. See the title block, the symbol of the drawing also it is given here. The symbol, I will come to this. Okay, the symbol of the drawing will give you whether you are using first angle projection system or third angle projection system. So for your purpose, the roll number, your semester, date, name, everything we can write here. Okay, like this. And coming to the size of the drawing sheet, so industrial drawings and all, they may use A3 sheet, A2 sheet, all those things they may use, and even A1 sheet also they will use it. But whichever the sheet that we have used, it is A4 sheet. Even our AutoCAD, the software you have used, you have taken A4 sheet, correct? A4 sheet, it is dimension is 210 by 297. Okay, 210 by 297. Similarly, A4 sheet. The A3 sheet is nothing but two A4 sheet together. If we keep, it becomes A3 sheet. Correct? Two A3 sheet if you keep together, it becomes A2 sheet. A2 sheet 2 if you keep together, it becomes A1. A1 2 sheet together if we keep, it becomes A0 sheet, like that. Depending upon the size of the drawing, industry people they use different the size of the drawing. That's all. Okay, see here. A4, A3, A2, A1, A0, like this. Different types of lines used. This you are all familiar with this. Okay, the like thick line, thin line, you have used it. So this thick and thin lines are recommended by the Bureau of Indian Standards. Okay, BIS is the Bureau of Indian Standard. This is the governing body. Based on this, their recommendations only we need to draw it. The various types of lines used in drawing, the different types of lines differ in appearance, thickness and construction. Let me show you here with the help of this. The continuous thick line you have drawn. So where you have drawn for this, visible edges or visible outlines in solids or in isometric or in planes, straight line. Okay, visible edge, whichever the line which is visible in that particular view, whether it is front view, top view or side view, there we have to use a continuous thick line. Continuous thin line, so only for the actual front view, top view or the object that is used, you need to use the continuous thick line. Rest of the lines are thin line. That is with the help of continuous thin line. For example, dimension line, extension line, projection line, XY line. So all those lines are thin line. So these things you won't be using it continuous thin freehand. Thick lines you have used. That is the dashed thick and dashed thin. Where you have used this in solids chapter you have used, as well as isometric chapter you have used. Okay, the edges are the outlines that you cannot see in that particular top view or front view. You have used dotted line. That is the hidden line you have used. So for that it is the representation. Chain thin used for the axis line are the center line you have used in solids as well as isometric. Correct? So other lines which are not used, this is the material convention. It is not required for you. Let me see. And this is the thickness which is which you have to maintain in your software. I have given here the thick line 0.4 millimeter. So in AutoCAD that you have to give, and 0.05 for thin line you have to give. That's what I have given here. Dimension plays a very important role in drawing. That's what. So we were discussing shape and size, right? So for that, the dimensioning is very, very important. So dimensions are indicated on the drawing to define the geometrical characteristics. So not only the shape is important, even size is also plays a very important role in the drawing. Geometrical characteristics in the sense such as it might be a length, diameter, radius, angles or location, whatever it is, which comes under your the geometrical characteristics. That's what which I have told. for describing any object, it is necessary to describe its shape first always, and then the size. First, for example, cylinder. First, I have decided to draw a cylinder. Next question, it comes to my mind in the sense, what is the size of the cylinder I should draw? Whether it is 50 millimeter or meter and 100 millimeter, the axis side, like that. So, this method of describing the size of the object is known as the dimensioning. So, dimensioning is nothing but, so to specify all the geometrical characteristics or to define the entire drawing, we need to dimension it. This representation of this, it is called as the dimensioning for this. So we may use the lines, we may use figures, we can use numbers, we can use symbols, we can use. So let me take one example and give you. So this is one example which I have taken here. Just one rectangle I have written with at the center I have drawn on a circle. Okay, so I need to dimension this. So I have drawn a extension line. So always while drawing, dimensioning it, always outside the drawing, I have to show the dimension line, and that too at least minimum 5 millimeter gap I should maintain from the your objects. What here you can see here the extension line I have drawn from the this end point, and then here I have drawn the dimension line. Okay, correct. And here so many things are there here. So here from and dimension, this is dimension line, this is extension line or projection line, and this is dimension figure, and this is ladder line. Ladder line in the sense, for example, this is a circle. I need to mention the dimension of the circle. So within the drawing I cannot mention it, it looks very odd. Okay, that's why I'm taking it out with the help of this line. It's an extension line which is called ladder line. I'm mentioning it here. The diameter of this circle, it is 10 millimeter. The symbol phi represents the diameter. Phi means diameter. So arrowhead. So what is arrowhead actually? Arrowhead will give the end, the point of your dimension. It is a termination, the point of your dimension line. That means this is the end of the arrowhead, this is the end of the other end. That means the distance between this point to this point, it is 50 millimeter. So like this. So like this we have to dimension. And coming to the different arrowheads, you can see here there are three the arrowheads are there. While drawing a arrowhead, so by this time you might have familiarized with this. By practice it will come, because every time actually the how to draw the arrowhead in the sense, the width of the arrowhead should be or length of the arrowhead should be thrice the time of the times of the width of the arrowhead. This is the convention we have to use. But while drawing our drawing, every time I cannot take my scale and I cannot measure the length of the arrowhead with respect to the width of the arrowhead. In such a case, by approximately I can draw it. There are three kinds of arrowheads are available here. One is open arrowhead, closed arrowhead, and closed and filled arrowhead. So this is open arrowhead. This is open arrowhead. So arrowhead is given, but it is not closed. It is kept open. Second one closed, where these two ends are joined with a line. It is called closed. And third one is closed and filled. So it's preferred to use closed and filled arrowhead. It looks better or good comparing to other two arrowheads. That's all. Next, coming to the units of dimensioning. So unit of dimension is also very important. Okay, so which unit, that means we are using for the dimensioning. So that's what a dimension should be as far as possible expressed in one unit only. For example, for length I cannot use in millimeter, for the breadth I cannot use it in centimeter, and this, the diameter I cannot mention with the help of the our meters. So whatever the dimension that you use, okay, in the entire drawing, only one unit you have to use. So the recommended unit, it is millimeter. The recommended unit for to dimension the object, it is millimeter by the Bureau of Indian Standard. And every time, Okay, after the dimension figure, we need not to write millimeter every time. It will obstruct the entire drawing, or else, or even it won't look good. Instead of that, what the Bureau of Indian Standard they recommends, so you write on footnote stating that all the dimensions are in millimeter. If you write this a footnote, then whatever the dimension figure you have used in the entire drawing, okay, so in that the millimeter is used as a unit, like that. That's all. This is about units of dimensioning. So coming to the dimensioning system, so already you have used it. Okay, let me give you the information about these two dimension system. The first one is called as the aligned system, and second one is called as the unidirectional system. Aligned system and unidirectional system. So with the help of this sketch, let me explain. Coming to the aligned system, so in this, in the aligned system, always the dimension figure is written above the dimension line. Whether it is the horizontal line or vertical dimension line, always the dimension figure is written above the dimension line. So for example, so this particular sketch which I have taken, so here the entire the drawing, so I have used aligned system. So you can see here, so this is the dimension line. Above the dimension line, I have written the dimension figure. So here also above the dimension, here also whether it is vertical or horizontal line, irrespective of the type of the line, above the dimension line, I have written the dimension figure. So this type of the dimensioning is called as the aligned system. Second one, the same sketch I have taken, but I have used unidirectional system. So unidirectional system, what it says, the dimensional figure always should be written at the open space left at the center of the dimension line, and it should be read from only from one direction, that is from left to right, like that. Okay, that means you can see here. So this is the dimension line, a open space which is left at the center of the dimension line. I am writing the dimension figure 20, irrespective whether it is horizontal dimension line or vertical dimension line. Here also you can see this is a vertical dimension line. Here also open space is left at the center of the dimension line, and the dimension figure is written only in one direction, so that I can read from left to right always, like this. So this is the difference between your aligned system as well as the unidirectional system. So you could able to differentiate here. Once again I'll repeat, aligned system, always the dimension figure is written above the dimension line, irrespective of the type of the dimension, whether it is horizontal line, vertical line, or even inclined line. So whereas in the unidirectional system, always the dimension figure has to be written at the open space left at the center of the dimension line, so that only in one direction I can read the dimension figure. That's why it is unidirectional, means one direction. And coming to the projection, entire the subject, we use this projection word, correct? Projection of points, projection of straight line, projection of planes, projection of solids, isometric projection, we use it, correct? So let me give you the exact picture, what exactly you mean by the projection. So any object has three dimensions, okay, such as length, width, and thickness. We can call it as a three-dimension object. So what is drawing actually? What we have discussed, a pictorial representation of any object is called as the drawing. Engineering drawing, how you have defined the representation of the three-dimensional object on a two-dimensional plane is called as the engineering drawing. Correct. Here, a projection is defined as a representation of an object on a two-dimensional plane. Whatever the object which is given to you, whether it is dimensional object like your point, the one-dimensional object like your straight line, two-dimensional object like your planes, three-dimensional object like your solids, whatever the object which is given to you, it is a projection is nothing but it is defined as the representation of an object on a two-dimensional plane is called as the projection. This is what you have done. So what was the principle of projection? So we have discussed this the principles of projections in detail. For example, let me take this example. Suppose if this is the object, so what exactly your the projection of principle says? Okay, by looking at the object, you have to identify the various contour end points of this. You have to identify how many points I'm getting. 1, 2, 3, 4. After identifying these points, okay, straight lines are drawn from this, like this. Straight lines are drawn from all the identified points so that it can meet a plane. Okay, I'll come to that. What is that plane? So after meeting that plane, we need to join those points with the help of a line. So once you join that, whatever the shape you are going to get, so that is your the projection. So that's what the principle of projection, what it says. If straight lines are drawn from the various points on the contour of the object to meet a plane, I'll come to that. What is a plane? The object is said to be projected on that plane. The figure formed joining the correct sequence, the point which these lines meet a plane, is called the projection of the object. The lines from that object to the plane are called projectors. That means, for example, this is your object, correct? You have identified 4 points and you have drawn these straight lines from these points to meet a plane. Whether it is front view or top view, we will go to discuss. Once it meet a plane, it will those points should be joined, and then whatever the shape of the the object that you are getting, that means object you are projected on the plane, it is called as a projection. Okay, that this particular the entire process itself is called as the projection, and then the lines formed the object to the plane are called as the projector. The lines, whatever the lines that you are the the drawing from the endpoints to the towards the plane projection, it is called as the projection lines or the projectors. So I'll stop it here today. So next class directly I'll take orthographic projection and we'll start with the 4 quadrant system as well as the points chapter are important. The exercises we'll discuss tomorrow class. So let me give you a brief introduction about orthographic and isometric projection. So orthographic projection, the word itself says ortho. What do you mean by ortho? It is 90 degree. Orthogonal is nothing but 90 degree. So projection principle, what it says, to draw the projection of any object, we need to identify the contour points. 4 points will be getting it. Then I need to draw a projector line or projector lines to meet the plane over there. Got it? And then we need to join. That is called as a projection. For example, if the object is very nearer to you, so you will look the object in a bigger size. The object is very far to you, then automatically the object will look like a smaller one. For example, in the class itself, if I show this object, those who are sitting first bench, they will see this the object in a bigger shape comparing to the last bench. Those who are sitting over there, they will see the object in a smaller size. If I draw a projection, so automatically the first bench student, they will draw a bigger the size of the object. The last bench student, they will draw a smaller size of the object. So orthographic projection, 90 degree projection, what exactly it says? The projector line, whatever you are drawing from the contour points, these projector lines should meet a plane at 90 degree exactly. And also if they are meeting at 90 degree, all the projector lines are parallel to each other. So then if this is followed, the person who is sitting in the first bench, second or last bench, everyone will look the same shape and size of this object are same. So this is the principle of orthographic projection. Isometric projection, any of the last chapter there I will explain. So almost all the entire basics are covered today. So next class I'll intimate you when we will have next class. So next class onwards, the orthographic projection I will give the introduction, and projection of points also I will be starting the next class. Okay, for today's class, if you have any doubts, just you can put it in chat box so that I can address to it for others also. So any doubts you have, you can post it in the chat.